This first lesson in Unit 7 is about inverse and joint variation. So by the end of this lesson, you'll be able to define direct, inverse, and joint variation and write examples of each type, and also apply models of inverse and joint variation to real data. The essential questions for this lesson are: how do I represent direct and inverse relationships? What is a joint relationship? And how can I apply direct, inverse, and joint models to real data? The vocabulary in this section is direct variation, inverse variation, constant of variation, and joint variation. First, let's define different types of variation. Direct variation should be a review from Algebra 1. But direct variation, we represent that by this equation: y is equal to some constant k times x, or this is the product of k and x. Generally, if we look at a graph of direct variation, it would look like this. So as x increases, y increases also. Examples of this would be something like the amount of time that you spend studying and the grade that you receive on a test. Typically, as one of those goes up, the other is going to go up also. Now, an inverse variation is when we have this equation: y equals some constant k over x. And actually, in both of these cases, for direct variation and inverse variation, that constant k cannot be 0. If I graph what this inverse relationship looks like, I have this. And so you can see with this one, as my x value increases, my y value decreases. And so a couple of examples of this are something like the resale value of a car versus its age. As its age goes up, the resale value of it would tend to go down. Or the speed that a car travels versus the time it takes to reach its destination. As the car goes faster, it would take less time to get there. One other term in both cases here, this constant k, that is our constant of variation. And in this example, how I correctly say this, the way that it's written, is that y varies inversely with x. In this next example, we will classify different kinds of variation. So we have three equations: y divided by 8 equals x, y equals x plus 8, and x times y equals 8. So the first thing we need to do is rewrite that in the form starting with y equals. So this first example would be y equals 8 times x. 8 would be that constant of variation k, and so this is a type of direct variation. This next equation is already in a form starting with y equals. However, it cannot be written as a product or a quotient involving k, and so this would be neither. And finally, this example right now is x times y equals 8, and I would rewrite this as y equals 8 divided by x. So again, here's my constant k, which is 8, and so this would be an example of inverse variation. The next piece that we are going to look at involves taking equations or taking values for variables and using it to find a value of our constant k, and rewriting our equation of variation and then using it to find a different value. So, for example, if y varies inversely with x. So that's it. That's all I'm given for this equation. So don't forget there also has to be a constant k in there. So that equation would look like y equals k divided by x, and x equals 5 when y equals -2. So I can use this to find a value of k. So y is -2, and that's equal to k divided by 5. So if I solve this equation, k would be equal to -10. So first of all, the equation that I can write from that is y equals -10 over x. And now I can use that to find any other value of x or y if I'm given another value. So in this case, I'm given that x is 2. And I can solve for y equals -10 divided by 2. And so now y would be equal to -5. Example 2 is direct variation. And so again, this is all we're given, is this y varies directly with x. So that looks like y equals k times x. And y equals -2 when x is 25. So that means -2 25ths is my constant k. And now I can use that to write my equation, y equals -2 25ths times x. And now I can use that to find x when y equals -40. So here I have -40 equals -2 25ths times x. And if I divide by -2 25ths on each side, I get 500 equals x. Now this last example talks about varying jointly. So the first thing we need to cover is, what does that mean? Varying jointly, or joint variation, means that a quantity is or varies directly with two or more products. So for example, we might say z equals that constant k times x times y. In this example, the variable z varies jointly with x and y, so it's going to be that equation there. If x equals 3, y equals 8, and z equals 6, we want to find z when x equals -4, and what I forgot to put in there is a y value, so when y equals 7. Okay, so the first thing that we need to do is figure out what k would be. So I have this starting equation, z equals k times x times y, and I know z is 6, so that's k times x is 3, and y is 8. Or 6 is equal to 24 times k, and 1/4 in this case is equal to k. So now I can rewrite my equation now that I have a value for k. So I can say z equals 1/4 times x times y. And now I have some new values for x and y that I can use to figure out what z would be. So z equals 1/4 times -4 times 7. And when I simplify that, z is equal to -7. Now the last thing we need to do in this lesson is apply this to some real data. So looking at this example, we're talking about force. So the force F needed to loosen a bolt varies inversely with the length of the handle. So that looks like F is equal to some constant K over L for length. So that's our equation that relates force and length. And now we know that 250 pounds of force must be exerted to loosen a bolt when using a wrench with a handle that is 6 inches long. So K over 6 inches. And we'll use K to then figure out how much force must be exerted when the handle is 24 inches long. So in this case, what I need to do first is figure out what K is, and that would be 250 pounds times 6 inches. That means K is 1,500. And now I can use that to write my new equation involving K. Force equals 1,500 over L. And so for 24 inches, I would say 1,500 over 24 inches. And the force there would be 62.5 pounds.